The goal of the project was for construction management students to work with architect students and students from Kenya to design specific aspects of a school building in a rural area in Kenya.
We're working on trying to get a computer lab built in Kenya for the students there. So we're kind of working with contractors in Kenya and informal labor and trying to design a structure and then send it over there to be built.
The goal of the HP Catalyst initiative here is to try and use technology to enhance the teaching of math and science in education.
Our school lacks electricity. Also, the teachers are there but not in permanent basis.
They don't have infrastructure. The school has only 2 classrooms, 2.
We were experiencing some difficulties in chemistry, especially in carrying out the experiments because we lacked the laboratory.
We have the workstations. We also have laptops for researchers. Now we've taken the workstations to secondary schools. We have downloaded simulation experiments to help the students to understand the experiments that they are missing from the real life situations. It's working, but I also believe that we still need more complicated experiments that can help them now understand it better in 3 dimensions.
We intended to design a learning experience for our students so that they could simulate a real-world design build competition by working on a project that was relevant and was actually gonna happen.
We had several phases in this project. First, the students in Kenya for the civil engineering department, they went to the rural school, they surveyed the site and they tested the material. Then our students here at the University of Washington, they used their results to come up with suggestions for the different materials that could be used in the school. Then another group of students designed the school, and then in the final phase, other students from the civil engineering department in Kenya, they will go in the construction site and use the suggestion that we provided to actually build the school.
Really, the goal of the project is to create a collaborative environment that's bringing students together in ways they might not have other places, to engage technology they don't have in other parts of their life.
We were divided up into groups. The groups consisted of both CM students and architecture students. That was done just to kind of get that dynamic between the construction side of it and also the more aesthetic architectural side of it.
My name is Tara Harrington and I am a construction management student here at the University of Washington.
And my name is Jake Antles. I'm a senior studying architecture at UW.
Our team researched various building materials, particularly for the roof and truss system. Specifically, I looked at alternatives such as sheet metal or reinforced concrete.
My team was in charge of doing the interior wall and floor finishes. I found it interesting that a lot of the materials that are used in Kenya are very similar to the materials that are used in the United States. It made research for the project a lot easier because we knew what types of materials we needed to look for.
My team was given a single contact, a student in Kenya, and we contacted via email. It was really interesting knowing that we were working on the same project, but we're separated by thousands of miles.
The best part about working on this project was being able to work with the architecture students here at UW, and we actually can see the results that we researched now going into play with the design and build of the Kenya project.
I plan on bringing kind of like a design-based knowledge, so trying to like think creatively for solutions to kind of, for maybe more like easily constructible building or like a better performing building.
I think the biggest challenges are going to be finding ways for the different disciplines involved and represented on the teams to get beyond just what they're trying to do and find ways to collaborate with others so that all the disciplines can meet their goals and so that all the disciplines can work together and hopefully create something that's better than they would otherwise.
Construction for Change is a Seattle-based nonprofit organization that partners with local organizations to build schools, hospitals, and other facilities where they're needed most. What we take for granted here, just quality, basic infrastructure, is just not happening there, and there's a big need for it. And as construction management students, this is where they could contribute.
You face a lot of challenges when you're in a third world country. The type of buildings that people are used to designing and building are way different than what you're used to, and so you have to learn how to adapt to that.
Are your doors always open then?
The truss space is open. The bricks all stop at that bearing height for the trusses. You can't go to the site, so it's really hard to design a building that makes sense for an area you've never been to and you can't go to.
Materials are not scarce, but you have to use them in a different way.
I think one of the biggest challenges, at least for our team, is to figure out how to use like some of the new materials that are available in Kenya that we don't really use here or design for here.
The question of building it could be a little bit more difficult. We don't want to have to be like cutting every brick or like shaving them.
Yeah. So from my experience, there are concrete columns and a little beam that would carry the entire load for the structure, and then they go back and refill with stone or brick.
What I took away from the meeting, it's that using the resources that are available is really critical. Also integrating it with the culture. People will walk over to see the building, and they kind of tend to take pride in this special building that was built for the community.
I was wondering if you had any experience on the availability of, methods on how to tie the trusses down.
Being a civil engineer, know what kind of sizing of different materials or the hardships of constructing a type of building like this. We had to troubleshoot a little bit and see how we can construct a whole entire school building without power tools, special forms and curvatures on the building to make this thing really constructible, but at the same time visually appealing.
The outcome of this phase is this final competition where students will present their final product. We have 3 teams of students that will be presented to a jury of industry representatives. Later we will hand over this information to our colleague in Kenya who will use them to build the facility.
We're here today to present our design on the Hafumbure Secondary School computer lab building. Temperature there is a considerable driving factor. We wanted the building to be able to cool itself off.
I'm a civil engineering major, so I guess I added some structural knowledge to the building. I was really happy with all my group members. They put in a lot of work, especially the architects designing everything.
This school should be people-oriented, user-oriented. It should be culturally acceptable to the local people there.
We developed a shading system made up of local material, which is bamboo. And those are located along our overhangs in those windows, those workstations, where students will be placing their laptops and will allow a lot of shading for those spaces.
What is sort of the life expectancy of the building and when things need to get done, more of a sort of a plan for the occupants to be able to take care of those items on their own.
Durability was an issue, but it was kind of this balance between conserving materials and then making the building more durable.
Our idea of durable is very different than it is in a country like this, where they have to kind of continually take care of things. So thinking about things that can be replaced easily.
I think our presentation went pretty well. Maybe some of your ideas stick and some of them don't, so just the kind of balancing act, and I think that is applicable to the real world and moving on into a career. So.
We are team number 2, and this is our presentation for the Kenya competition.
The goal of this project for our team was to kind of design and develop a building that not only could be built for this school, but could also be replicated.
One of the materials that we're pretty excited about is our use of the rammed earth. The thickened rammed earth will provide some protection for that heat and give us kind of a natural cooling element.
Additionally, we're using locally sourced brick that we cast on site. They're non-standard, so that's something that we had to play with a little bit, how it worked, something that's not going to be a very specific size into the program.
We're attempting to equip the people in this region to make other buildings of this sort. They can easily make this again for another use in another location.
We tried to design for this school, but also use techniques and materials that were easily accessible and could easily be constructed in that area.
I really appreciated your thinking about, in terms of all the different materials and thinking beyond just making the building, but thinking about the local economy, perhaps engaging women. I think that's really an important aspect to working in these types of contexts.
We all worked together really well and we were able to put out a good project.
We looked at a lot of images of schools in Kenya. We knew that we wanted our structure to be a gateway or threshold experience into this interior sanctum that they're proposing in their master plan. If this were to be built, it wouldn't just be a school, it would be a beacon of the community. And the goal for us was really to create a thermally comfortable space that was well lit year-round.
As all the sun beams down on this metal roof, it's going to radiate heat, and that's going to make the space feel really hot. So we have to keep that in this high zone, and then allow the airflow to shoot through there and carry it off.
Truss 2 is a lot different than Truss 1 because they don't have that bracing into the columns.
I brought a little bit more about structure analysis to the group. I thought that was my key role in the team. Working with architects, that was great. I learned how efficient they were. It was a good experience for me to have.
I'm kind of blown away by the thoroughness here, just with all of the diagramming, all of the drawing, just the care, obviously, that you guys put into this.
When I watched you guys present, my reaction is, man, that would be a fun building to build. I get excited about constructing it, which is cool. My only comment on some of the stuff is the louvered windows and the rotating doors.
We knew that the windows and doors might be a problem, but we wanted to shoot for the design ideal, and knowing that they were going to change it.
If you guys would be committed, it's very, very well done.
It's kind of eye-opening. You go from designing for projects in Seattle where you have accessibility to everything to designing for places that don't have those options, and it's definitely challenging.